fifth term of the sequence defined by the formula a sub n is equal to the quantity of negative 1 raised to n plus 1 times n. Substitute n is equal to 5. A sub 5 is equal to the quantity of negative 1 raised to 5 plus 1 times 5, which is equal to negative 1 raised to 6 times 5. Take note, if you raise it to 6, it will become positive 1. So it will be 1 times 5. So a sub 5 is equal to 5. What is the 30th term of the sequence? 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, and so on. If you check the pattern, you'll notice that the first term is 1, the second to third term is 2, the fourth to sixth term is 3, and the seventh to 10th term is 4. And if you add the digits from 1 to 4, you'll get 10, which proves that the 10th term is 4. If you add the digits from 1 to 7, you'll get 28. So the 28th term is 7. Therefore, the 29th term is 8, and the 30th term is 8. Another solution to know any nth term, multiply the nth term by 2, find the square root, and you get the number and round it to first decimal place. The 30th term is equal to square root of 30 times 2, which is equal to square root of 60. So the 30th term is equal to 7.75, or 8. What is the sum of all odd integers between 6 and 30? The formula for the sum of an arithmetic series is S sub n is equal to n times the quantity a sub 1 plus a sub n all over 2. There are 12 odd numbers from 6 to 30 as seen below. A sub 1 is 7 and a sub 12 is 29. Now substitute. S sub 12 is equal to 12 times the quantity 7 plus 29 all over 2. So S sub 12 is equal to 12 times the quantity 36 all over 2, which is equal to 12 times 18. So S sub 12 is equal to 216. The 30th and 50th terms of a geometric sequence are 5 and 6 respectively. If the last term is 36 all over 5, how many terms are there in the sequence? Here's the formula for the last term of the geometric sequence. A sub n is equal to a sub 1 times r raised to n minus 1. Change a sub n to a sub 50, a sub 1 to a sub 30, n to 50, and 1 to 30. Now substitute. A sub 50 is equal to a sub 30 times r raised to 50 minus 30. In the given, a sub 50 is equal to 6 and a sub 30 is equal to 5. Then, 6 is equal to 5 times r raised to 20. Now, transpose 5 to get r raised to 20 is equal to 6 all over 5. Using the given, we could say that the last term is 36 all over 5. So 36 all over 5 is equal to 5 times r raised to n minus 30. Transpose 5 to get 36 all over 5 times the quantity 5 is equal to r raised to n minus 30. So 36 all over 25 is equal to r raised to n minus 30. Let's square r raised to 20 is equal to 6 all over 5 to get r raised to 40 is equal to 36 over 25. Equating 36 all over 25 to 36 all over 25, now we have r raised to 40 is equal to r raised to n minus 30. So 40 is equal to n minus 30, therefore n is 70. If a sub 1 is equal to 1, what is the fourth term of the sequence defined by a sub n plus 1 is equal to 1/2 times the quantity a sub n plus 5 all over a sub n. N is equal to 1, substitute to the equation, a sub 1 plus 1 is equal to 1/2 times the quantity a sub 1 plus 5 all over a sub 1. If a sub 1 is equal to 1, then a sub 2 is equal to 1/2 times the quantity 1 plus 5 all over 1, which is equal to 1/2 times the quantity 1 plus 5. So a sub 2 is equal to 1/2 times 6, which is equal to 3. When n is equal to 2 and a sub 2 is equal to 3, then a sub 2 plus 1 is equal to 1/2 times the quantity a sub 2 plus 5 all over a sub 2 is equal to 1/2 times the quantity 3 plus 5/3, which is equal to 1/2 times 14 all over 3. So, a sub 3 is equal to 7/3. When n is equal to 3 and a sub 3 is equal to 7/3, a sub 3 plus 1 is equal to 1/2 times the quantity a sub 3 plus 5 all over a sub 3, which is equal to 1/2 times the quantity 7/3 plus 5 all over 7/3. So a sub 4 will be equal to 1/2 times the quantity 7/3 plus 15 all over 7, which is equal to 1/2 times 94 all over 21. So a sub 4 is equal to 94 all over 42. Simplified, it's 47 all over 21.